Section 3 is multiplying binomials. So we've, in the last section, distributed. We used the distributive property. Now in this section, we're going to multiply a binomial times a binomial. When we're using the distributive property, it looks more like a monomial times a binomial or a trinomial or some other type of polynomial. Okay? So now we're going to take two binomials and multiply them together and see how we have to do that. And pretty soon, you'll be able to take any size polynomial times any size polynomial once you learn this first little bit. So, back to the 5th grade for a minute. How do we multiply 34 times 27? Okay, so you multiply 7 times 4. And what is 7 times 4? Okay, so I write down the 8, and I carry the 2. And then I go, 7 times 3 is, and then add the 2 and I get 23. So I write down 238. I'm not done though. We got to put a 0 down right here, because really what you're doing is you're saying, all right, now what I'm doing is multiplying 20 times 34. I don't know if you know that or not, but that's why I put the 0 there. So then we go what? 2 times 4 is, okay. 2 times 3 is 6. And then what do? And then we add up all those columns that we found. The ones column, add them together. The tens column, add them together. We had to carry a 1 there. And then the hundreds column, 9. So the answer to that problem is 918. All right, stay in 5th grade, and I want you guys to do this problem here. What do we get? Okay, so 2 times 5 first is 10, carry the 1. 2 times 6 is 12, plus 1 is 13, carry the 1. 2 times 2 is 4, plus 1 is 5. Put down a 0. 9 times 5 is 45, carry the 4. 6 times 9 is 54, plus 4 is 58. Did I make a mistake somewhere? Carry the 5. 2 times 9 is 18, plus 5 is 23. And we add up all the like places. So the ones place, the tens place, the hundreds place, carry the 1, the thousands place, and then the 10,000s place. There's your answer. Well, the reason I wanted to show you this is because what we're about to do in this section is just like this. If you can handle this, you can handle what we're going to do today. So I want to point this out to you. I don't know if you realize this or not, but what you did was, on this problem right here, you multiplied this term by both of these two things right here. You took that 7 and multiplied it by that 4 and by that 3. And you also took that 2 and did the exact same thing. You multiplied it by that number and that number. On the other problem, you basically did exactly the same thing. You took that 2 and multiplied it times that 5. You multiplied it times that 6. You multiplied it times that 2. Then you took the 9 and multiplied it times that 5, multiplied it times that 6, and multiplied it times that 2. You've been doing that since the 4th grade probably. I wrote 5th grade up here, but probably the 4th grade. You know how to do that. Okay? Multiplying polynomials is exactly the same thing. If I had a third term here, like if I had a 4 sitting there, it was 492, then I would take that 4 and multiply it times that 5, multiply it times that 6, multiply it times that 2. Basically all you're just doing is distributing. It's basically the distributive property that you've been using since the 4th grade, and you didn't even know it. All right, so do the same thing with polynomials. Multiply each term in one polynomial with each term in the other polynomial. Just like we did back in the 4th grade with regular old numbers. So, here we go. Find the product. This is what your problems are going to look like. You'll have a binomial and a binomial, and what's going on in between those two binomials? Multiplication, right? How do you know it's multiplication? Right, if there was a plus sign or a minus sign in between, that would just be section 1. That's what we did in the first section of this chapter. But there's no sign in between. That means I have to multiply these two together. So to multiply these two together, I want to set them up just like I did in the 4th grade. This is just like 63 times 24, or whatever it was that we had. Okay? The first thing we did was multiply these two numbers. We're going to do exactly the same thing here. 3 times 5 is 15. The next thing we did was multiply these two numbers. We're going to do exactly the same thing here. 5 times 2x is 10x. So I'm going to write 10x, and that 15 right there was a positive 15, so I'll put a plus sign in between. Then we move on. Over here we would go 2 times 3. So on this one we're switching terms. We're going from x times 3, which is 3x. Now I'm going to write that directly underneath that 10x because those are like terms. So I write 3x there. And then finally, we would do 2 times 6 on the 4th grade problem. So here we're going to do x times 2x, which is 2x squared. I don't have a like term with that one, so I'm going to write it over here, 2x squared. That was a positive 3x sitting there, so I'm going to write plus 3x there. And now what am I going to do? Add them together, which is combine like terms. So I draw a little line here, and I add these things together. Nothing plus 2x squared is just 2x squared. 10x plus 3x is plus 13x. And then 15 plus 0 is just 15. Plus 15. There's your answer. That's it. It's exactly the same thing as 4th grade. It just looks a little bit different is all. But the process is the same. Okay. So you see I wrote the vertical method here. That's because I took this problem and I wrote them vertically. The binomial times the binomial. This little x in parentheses over here is supposed to say times. All right? There's no good way to write that anymore because we're using the letter x in the problem. So that just meant times. The horizontal method is a little bit different. Notice that each time we took each term and multiplied it by both terms in the other problem. So here we need to take this term and multiply it by this one and this one. And we need to take this term and multiply it by this one and this one. Just like we did over here. Okay? So in this problem, the first thing we did was 5 times 3. So over here we'll do the 5 times 3. And we get 15. On this problem, which was just like the 4th grade problem, the next thing we did was this 5 times 2x. So we'll do the same thing here. The 5 times the 2x, which is a positive 10x. So I'll write down plus 10x. On this problem, which was the same as this problem, basically, the next thing we did was x times 3. So we'll do the same thing here. X times 3, which is 3x. So plus 3x. And then on this problem, the last thing we did was x times 2x. So we'll do x times 2x on this one, and we get 2x squared, so plus 2x squared. Now what do we do? Combine like terms. It's not add here, it's combine like terms, but it's basically the same thing. So on this one, we've been trying to write things in standard form all along. So I'll try to write this in standard form as well. What term should I write down first? The 2x squared, correct. And then my next term will be the 3x and the 10x becomes 13x. So I write plus 13x. And then finally that plus 15. And there's your answer this time. Notice you got the same exact answer both times. So we call it the vertical method or the horizontal method. Either one of those works for when you're multiplying two polynomials together. So whichever method you prefer on this one, go ahead and multiply those two binomials together. You can use the vertical method or the horizontal method, whichever one you like better. So let's see the vertical method first. What am I going to write? The top or bottom doesn't matter on that. So I'm going to multiply. Negative 2 times 4 is negative 8. Negative 2 times 3x is negative 6x. And then we switch. X times 4 is 4x. And where do I write that? Underneath the negative 6x, yeah. So 4x. And then x times 3x. So 3x squared, and that's a plus 4x there. So then I draw my line and I add these things together. Well, you wind up with negative 2x. So that's minus 2x minus 8. So there's your answer for the vertical method. Now the horizontal method, basically I'm doing exactly the same thing. First I did the negative 2 times 4. So negative 2 times 4 is negative 8. And then negative 2 times 3x. Negative 2 times 3x. Negative 6x. And then the next thing I needed to do was this x times 4, which was positive 4x. And the last thing I need to do is this x times 3x, right there, which is positive 3x squared. So then I need to combine like terms in standard form. Here's my first term right here, 3x squared. These combine to give me negative 2x, so minus 2x, and then this is negative 8. We wind up with exactly the same answer in both cases. So both of those methods work. But basically what's happening is you are taking that first term and multiplying it by both of these second terms in the second thing. So x times that 4, x times that 3x. Then we're taking that negative 2 and multiplying it times the 3x and also by that 4. Okay? Which method is better? You like the vertical one. Yeah, most people do when they first start learning it because it reminds them of the things that they've learned before back in like the 4th grade. So, vertical method, perfectly fine. Horizontal method works just as well. And actually, this is the method that we're going to prefer to use here, like even on the next page. So I am going to ask you to do the method that's on the next page, even though you like the vertical method better. What you were doing with that horizontal method is actually called the FOIL method. If you ask people in algebra or algebra 2 who have taken algebra 1 before, if they know what FOIL means, they'll be like, yeah, I know what it means. Because that's one of those things that you don't ever forget after you've taken Algebra 1. It just sticks with you for forever. Everybody remembers FOIL, pretty much. FOIL is an acronym. It stands for something to help you remember how to multiply together two binomials. So when you have two binomials being multiplied, you can use the FOIL method. FOIL stands for first terms, outside terms, inside terms, and last terms. So if you can remember FOIL, first, outside, inside, last, or first, outer, inner, last, then you could remember how to multiply these together, and you won't lose terms or make mistakes. So, first of all, the F in FOIL stands for the first terms, and what that means is the first term in each one of these binomials. These two guys right here are the first terms. That's your F. The outside terms for O means the two terms that you see on the outer edges of the problem. So those two guys right there, that is the O. And all you're doing basically is distributing that x in. Think of this as like distributing the x into both of those terms. If there was no 4 there, you just multiply in that x, just like the distributor property. Okay? Okay, that was O. The I term is the inside terms. If the two outer ones were the ones that were O, then the two inner terms are the ones that are I. So that right there is the I in FOIL. There is I in FOIL for sure. And then the L, the last terms, the only two that we haven't multiplied together yet, just because just like these two here were the first terms in each binomial, these two guys are the last terms in each binomial. This is the L in FOIL. That is how you do these problems. I know that the vertical method makes a lot more sense to you probably, but as you get practice with these, you'll get to the point where people will use FOIL as like a verb. They'll say you can FOIL that together or FOIL it out, and I'll say that too. We're just going to FOIL it, okay? It's almost like a verb. It's not even a word, but we say it like a verb. We're FOILing some stuff today. That's what you need to know. That's how you got to remember it. So, use FOIL to find the product. Well, the first thing I'm going to do, and by the way, feel free to copy down your problem and draw out these little things to help you remember. So that's what I'm going to do for these first couple problems. We're using FOIL. F stands for what? The first terms. And the first terms are the first terms in each of the binomials. Those two right there. When I FOIL that, what do I get? 6y squared. Good. And by the way, as long as things are written in standard form, which all of these binomials that we have are, the reason that you go with FOIL is because when you're done, everything is going to be in standard form already for you, which is really nice. So that was F. What about O? What's O? The outer terms. That's this guy and this guy. So I'm just distributing that 2y into that one as well. And what do I get? So plus 10y. What's my next one? The inside terms, or the inner terms. That's which two? The negative 7 and the 3y. So I'm going to go negative 7 times the 3y, and I get negative 21y. And then the L is the last terms in the binomials. The last term in this binomial is that negative 7. I'm going to multiply it times the last term in that binomial, which is that positive 5, which gives me what? Negative 35. Now when you do these problems, just like with the distributive property, which by the way, that's what this is, basically, you're just distributing twice is all. What do you have to do? Always combine like terms. There's almost always going to be like terms to combine on these problems. So we do have like terms here. We get 6y squared, what? Yep, so minus 11y, and then the minus 35. There's your answer. So FOILing's the way to go. But remember that vertical method got us to FOIL. So the stuff that you were doing in the 4th grade got us to the vertical method for multiplying two binomials together. And then as soon as we did that, we could see that this horizontal method actually worked. And now we're going to put a name to it and call it the FOIL method, so that as we multiply these terms together, we wind up in standard form, which is very nice. I'd like you to do that second one. Watch out for your minus signs. All right, talk me through it. Four a times 2a, so f, and we get 8a squared. Good. The 4a times the negative 9 for the O part of FOIL, and we get, pretty sure it's negative 36a, okay. And then negative 5 times 2a for the I part of FOIL, negative 10a. Positive 45 for the L part for FOIL, the last terms. Combine like terms, and we get what? And you're done. So let's do that first practice problem here. What do we get? The f is the first term times the first term, which gives us x squared. The O is negative 4x. The I is plus 3x. and then the L is negative 12. And like I said, you don't have to draw those in on those problems, but it definitely helps, especially in the very, very beginning when you're first learning how to do this. Either way, what do we do now? Combine like terms, so we get, and there's your answer. Okay, this is probably the last time you'll see me draw these things up here, except for one more problem a little bit later on. How about this one? So 12b squared. Good. 8b. Right, watch those signs. Minus 15b. And then minus 10, yep. So we get good. 8b minus 15b becomes negative 7b minus 10. Done. All right, the bottom two are yours. Draw the lines if you need to, or the little arcs if you need to. Watch your signs. Watch out for multiplication mistakes. Go ahead. What's my first term? Two y squared. Call on somebody else. Minus 12y. Good. Call on somebody else. Good. Minus 5y. Negative 5 times negative 6 is positive 30. Okay, so what's my answer then? Yep. Yep. Very good. All right, call on somebody. A squared is correct. Next. -20? 20a, good. And good, plus 6a, and good. 2 times negative 4 is negative 8. So then our answer is who are you calling on? Go ahead. Good. Combine these like terms and you wind up with minus 14a and then minus 8. That's the correct answer. Very good. Okay, so that was the FOIL method. So now we've learned the vertical method, the FOIL method, and here's another method for you to multiply two binomials together. This one actually pays off really, really well. So we don't usually use this one on problems like this. We use this one on problems like we'll have in a little bit. And then we use this one on problems that we'll have in the next section for sure. This one's called, I call it the box method. It's actually called the area method. So I'll put a little area underneath the word box, because actually what you're doing is you are multiplying together side lengths of rectangles to make areas. I'll show you what I mean here in a minute. So set up each term of one binomial along the top of the box. Okay, so on this problem, here's one binomial. I'll put 2x here and 3 here. It's a math Punnett square, that's right. For those of you who have had, what class is that? Biology. Good. Each term along, for the other binomial along the left side of the box, so that would be x here and 5 here. And then for those of you who have had biology, what are we going to do? Yep, you multiply this guy times this guy and write the answer there. This guy times this guy and write the answer there. All right, that's all that's saying. Multiply each term on the left by each term along the top and write each answer in the corresponding box. Then combine like terms and you're done. This is a great method to do exactly the same thing that we've been doing. So I have x times 2x, which is 2x squared. I have x times 3, which is 3x. I have 5 times 2x, which is 10x. And this is 5 times 3, which is 15. Then we combine like terms. They're all sitting right here. The 2x squared we'll write down first. The 10x and the 3x plus 13x. And then finally that 15 plus 15. And we're done. Yeah, most people really do like it. And it's important that you learn it because when we start to go the other way, factoring, the box method will come back and it really, really helps. So go ahead and try this one using the box method this time. So what do you want to write across the top? And it is -5 there, okay. And down the side? And -9, good. The signs still go with the term, so if you see a minus sign, it has to go with that term. So think about this box method this way. Notice I called it the area method. The reason it's called the area method is because if you think of this length right here, if that length has a dimension of 4a, and this length right here has a dimension of 2a, and I want to find the area of this box, well, it'd be a rectangle, yeah, you're right. But if I want to find the area of this thing, then I'm going to multiply this length times this length, and I would wind up with 8a squared for my area. That's all it is you're finding areas. So then I have this length, which is the same as this length. So that length right there is 2a. This length would be -5. So then I have 2a times -5, which is -10a for an area there. And the same thing happens here, -9 for that length, 4a for that length, and I wind up with -36a. And then +45. So then I combine like terms as I write these things down. What's my answer? And that is the answer. Okay, so that's the box method. And we had 4 practice problems with the FOIL method. These are exactly the same practice problems, but we want to use the box method this time. So I'll go over the box with you. You don't have to draw a gigantic box when you draw the box, just big enough to put terms into. So I'm going to write a little box like this. Terms across the top, x and 3. Terms down the side, x and -4. And then I'm going to multiply all those things together. So I have x times x, which is x squared. I have x times 3, which is 3x. I have x times -4. What is that? -4x. And then the last one will be -12. So then my answer is x squared minus 1x, or just minus x, minus 12. And you're done. Notice I didn't have to draw in a gigantic box there. Just big enough for me to fit all of my terms inside was perfect. So let's go ahead and do that second one. What do I do? Draw the box. So 4b and -5. Okay. 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 So then my answer becomes -10. There you go. Go ahead and do the last two. Box method. So on this one, we draw the box. Across the top. 2y -5. Down the side. Y -6. 2y squared. Negative 5y. Negative 12y. Positive 30. So in the answer it becomes correct. And the last problem, draw the box. Okay, now before we go on, does it matter if I put the 5a and the 2 on the top? Can I put the 3a and the negative 4 on the top? Yes, I can. It'll just kind of trade around where those terms wind up in the box, and that's perfectly fine. I'll still be able to combine like terms, and I'll get the same answer. Okay? So, what do we get inside? Okay? All right, so my answer is done. What are we doing here? Yeah, we're taking a binomial and we're multiplying it times a trinomial. What about this one? A trinomial times a trinomial. Now I'm going to show you that you can do this using like the FOIL method. It's just distributing this term into all three, and then distributing the next term into all of them, and then distributing the next term into all of them. Yes? Yeah, if you want to think back to like 5th grade, you'd have like a number with 3 digits times a number with 3 digits. Exactly. So we can do like the FOIL method. We take this term times that, this term times that, this term times that. We're just distributing the 6x into all three of those guys. And then we're taking that 5 and doing the same thing. Distribute that 5 into all three of those guys. And then you'd have to combine like terms. Okay? You can use the box method on that. And please, on problems like this, please use the box method on this. Because here's what happens. As you start going through, and especially on a problem like this, like on this one, I'd have to go this one times this, times this, times this. And then this one times this, times this, times this. And then this one times this, times this, times this. And it kind of makes a cool looking picture. But what happens when you're right here and you're multiplying by one of these terms and then you sneeze and you got to go and get a Kleenex because something terrible happened? Now you come back to your homework assignment, you have no idea where you're at. But if you're using the box, you're filling in each one of those positions as you go, and now you can go get a Kleenex and you can go play 9 holes of golf and come back and you'll know exactly where you left off. It won't be an issue at all. So you want to use the box on this one. What? Well, you'd only play 18 holes because you're not 21. Yes, exactly. This is a binomial here, a trinomial here, so I need a rectangle looking shape with 2 and then 3 so that my binomial can go here, 6x and 5, and my trinomial can go here, 2x squared, negative 3x, negative 5. So now it's all set up, and all we got to do is exactly what we were doing, like with the Punnett square type looking thing on the last problems. So we go 6x times 2x squared is 12x to the third. 6x times negative 3x is negative 18x. 6x times negative 5 is negative 30x. And then down below we have 5 times 2x is 10x squared. Then 5 times negative 3x is negative 30. Oops. See, I got ahead of myself. I'm so excited. So I need blue to fill in that hole, and then I need red. Okay, 5 times negative 3x is negative 15x, and then 5 times negative 5 is negative 25. Now we just got to combine like terms. What's the first term we're going to write down? 12x to the third. That's the highest degree. I left off a square here, sorry. And then we have the 10x to the second, but that's a negative 18x to the second. So we get minus 8x squared. And the other nice thing is about this, as you go, you can start crossing things off. Like I used that one, so I cross it off. I used both of those, so I cross them off. And then I have these like terms for a total of negative 45x. They're gone, and now I'm just left with that minus 25. Now all my terms are combined, and I'm in standard form. There's your answer. So we're almost out of time, but let's take a look at this last one right here. Instead of doing it like this and getting lost and confused, we're going to set up a box. A 3x3 box. That's right. So we'll start next time with this 3x3 box here, just to kind of warm up, and then we'll take care of these two problems, and we have one more problem after that.